all with the problems and challenges that we encountered while taking on this project. Finally, we'll then have some future recommendations and for upcoming PDCC members that are still yet to be part. Next slide. Okay, so we did took our time to evaluate multiple storage softwares, which ranges from Google Drive, iDrive, SharePoint, Box, G Suite, and many more. And we come to the point to pick just Google Drive and G Suite as one of the more user-friendly and accessible storage software. So when we are done with that, having those two softwares, we then moved on how to have the data being arranged and for easy accessibility for anyone that would be using these storage software in subsequent times. So we did arranged all of those data. After having a design data hierarchy, we then have it implemented in the new software, which is the G Suite storage software we would be using. So our team took the time to also develop admin manual for anyone that would be partaking in the usage of this software. So basically, it would help anyone that has not been part of this team that have put up this data in according to its time, would be able to make good use of them with the manual that we've created. Next slide. Okay, so first, the most important part of it all was we all approached this project as a group. We ensure that we all are well informed with good form of communication, which was a very important part, though we live far apart, but with the use of WhatsApp, that has enabled us to get most of everything we were doing accordingly. So we were able to set deadlines to enable us work towards those goals. Without deadlines, we wouldn't have been able to have most of our goals completed. So working as a group, using a good form of communication, which we use WhatsApp and Google Hangouts, because we use WhatsApp for communications, for texting, getting everyone notified about information. Then we'd also use Google Hangouts to actually share screens, talk about the new changes we'll do, and also finally make final adjustments while we are all looking at the screen of each other with Google Hangouts. So finally, we try our best to have our meeting once a month to make sure we have things aligned. So working as a group, having a very strong form of communication with use of WhatsApp and Google Hangouts, we're able to have all of our goals achieved. Next slide, please.
Okay, thanks, Chidubem.
Okay.
So we did a storage software analysis, and you can consider this maybe as a small feasibility study for what would be best for the Collegiate Council. And on the screen, these are some of the criteria that we had: minimizing the cost, fast turnover, something that's familiar already with what we're using, and something that the mentors and Danielle emphasized on is that we really want to find something that allows adding permissions to users. So having some kind of admin hierarchy, and data recovery was very important. Oh, you can go ahead, Nathan. So this is an exhaustive list of every single software that we looked at that was popular So you can see that we have Sync, G Suite, Google One, pCloud, iDrive, Box, SharePoint, and it's an exhaustive list. So we put together criteria that we believed that would make the Collegiate Council very successful when it came to data management and future data management. And some of the runner-ups, definitely the top three were Google Drive, Google One, and SharePoint. And Google's G Suite is a add-on tool for Google Drive, and we've noticed that this complementary software met the criteria that the mentors wanted, and it also met our criteria. So here are the three that I mentioned that met the top three, and this is not every single criteria, but these are just some. So it turns out Google Drive was the most cost effective, and when we did this small little feasibility study, the metrics showed that Google Drive was the most optimum for our uses right now and in the future. And it also turns out that we are currently using Google Drive right now for data storage, and we are not using it at the fullest capacity that it was designed for. So we also saw that as a flaw in our current data storage problem. So Google One is more of like a corporate storage for like a big corporation that many people can access. And it's not exactly what we're looking for when it comes to ASME PDCC. SharePoint was definitely probably number 2 runner-up. This is a Microsoft software. However, we believe the costs actually go up tremendously for data storage, and the transition, there was a little bit more of a transition because not everybody's familiar with SharePoint. So most people, everyone here currently uses Google Drive. So we decided to go with Google Drive. So why Google Drive? We saw that it was optimum for the storage capacity and price, the number of users and permissions allowed. So the mentors hit on the point that they wanted some kind of admin structure, like I mentioned. Have a way where previous members that are retiring can have access to some kind of information in the drive, but maybe not have all the information available to them that would be conflicts of interest or what have you. So we wanted something where members retiring from the program can have access to information, a contact list, and so on, while the current members can be kind of inaugurated to the current drive and able to access all the data needed for their projects. This definitely optimized collaboration among the members. We can easily communicate and access the data that we put on the drive and share that to other members as needed. The data recovery definitely met the mentors' standards, and there's also additional data recovery options you can add to even have this data perpetual. So in a sense of the data never gets deleted. So you can delete it, but it's always stored in a vault where you can access it. So overall, we're all very familiar with this already. It was very flexible. It was a very slow transition time, and it's very customizable, as the other members will show you that when it comes to the data hierarchy on how we store the data, that is completely customizable, and we made it possible so that it's very effective in communication. It takes the fewest clicks possible, and it's just very efficient. So that's the mindset we had. So overall, yeah, it was very low complexity, and the cost, it was very cost incentive. It was about $6 a month for the G Suite edition, and Google Drive's already free. And our data storage needs, we don't anticipate going over 15 gigabytes. However, in the future, as we add more videos and photos and PowerPoints, we could be approaching that 15 gigs, and we can look into additional storage opportunities in the future for that. Oh, Nathan, sorry.
All right, thanks, Jamie. Okay, so once we chose the storage product, the next step was to organize the data from prior PDCC councils and this year's council. So these are the three main things we wanted to look at. We want to focus on minimize clicks, leverage the knowledge of the ASME PDCC workflow, and keep data generalized and easy to manage. So going along with that, we wanted to make it accessible and user-friendly. We wanted new people coming in, whether that be members or mentors, to easily be able to go to the PDCC G Suite and look at all the data. So we've all dealt with an Excel file or some sort of data where somebody says, you know, everything's there, go find it. But it's like, yeah, everything may be there, but it's not organized at all. So it makes it really difficult to work with. So that was our main idea. We wanted a logical, clear layout, sustainable year to year. So it's really easy to add the current year PDCC files and keep it a similar format. Let's go ahead with the next slide. So this is the kind of the general design we had. So ASME PDCC file, then we split it up by years. So this goes back a couple more, but these are just the examples. And then along this tier with the ASME PDCC years, we also have a common file that doesn't really fit into any specific year. That may include current and prior mentors, contacts, operating manuals, stuff of that nature. And then each year, the projects, the teams, the participants are different, but the categories are the same. So every year that you have a project, every year you have teams. So we thought that was the best way to split up how the data was organized. And so an example here we have for the database. So we have our first and second meetings. We have the project. And of course, the final presentations. And you could add in here initial or working presentation or something like that. But basically, the idea is that they're all similar across the years. So it's pretty easy to add new stuff and search for old stuff. So yeah, that's basically as far as our data management. Once we chose the system to use, that's how we went about setting it up. And thank you, Don, for a lot of your good notes and all the feedback that both of our mentors gave. Really helped us out.
Thank you, Teddy. So I am speaking with you about the admin manual that we created. It's a 30-page file that helped the admin to handle the data. So I have attached a link in the Zoom message for the of the manual for the executive committee's reference. It's a 30-page manual that really helped to organize and manage the files in a proper manner. So it teaches how to add a new member to the drive and leverage G Suite admin tools, and also how to delete and how to recover the lost data, and also mention the hierarchy level also. Next page, please. So this is just basic content of the admin manual. So which help whoever handle this admin role. Right now, Danilia is handling, but if you give the responsibility to any new members, so it will really help the member to go through this database and do their stuff. That's it. Thank you.
Thank you, Jithu. And with that, we'll focus on the results of our project. So what we were able to get from this project is we developed a new admin manual for the data admin to focus on and use to standardize all the database processes. Because a big thing when it comes to computer science is keeping everything really standardized and making the workflows as efficient as possible. The next is keeping Google Drive as a storage software. Again, we chose that because it had the most common application among students, and also cost effectiveness. And now with the G Suite admin tool set, we would be able to really unleash the potential within Google Drive and give it that next level above its competitors that it needed before. And then our new data hierarchy will allow for a limited amount of clicks and standardize the folder sets. So each year can just copy and paste that folder set and then replace all the files within it. So we don't have to keep making new files every single year and really just cleaning up all of the data that we currently have available. So this is currently what our G Suite folders look like. Ignore the names to the right of them. That was just to assign different team members who would make the different folder hierarchies and store all the data in them. But you can see that we have all of the collegiate councils in by year, and as well as the common documents as well associated with them, all under the ASME PDCC folder. And then if we go deeper into the CC 2020-2021 drive, we can see under there we have completed projects, team mentors and interns, the videos and photos for that specific year. And then inside the team mentors and interns, we have the specific intern folders, which you can go in for all the intern data. You can go to mentors and staff, which take care of all your mentor and staff data, and the project teams. And under there, you'll see the database team, PFS team, all the other things associated with it. And then within there, there's the current working documents and the documents that have been finished, along with the final projects, if that year has already been completed. So some problems and challenges that we focused on and came about during our project was ensuring that we kept costs down, because a big thing is we might get a really nice data storage software, but if it costs $50 a month, that's not really economical for our situation. We also had some difficulties with the coronavirus, because obviously that caused a lot of travel issues, communication issues. It really just messed with people's schedules, because not only are we ASME PDCC members, but we're also students as well. So on top of all of the logistical difficulties caused in the Collegiate Council, we also had to deal with how our school life was changing as well. And I'm sure a lot of us experienced some family changes as well, in terms of just making sure everyone's safe and sound, and moving around logistically, maybe going in and out of dorms and those types of situations. And then the other problem we had was there's a large variety of data storage softwares out there, so we couldn't evaluate all of them, even if we'd like to. So what we tried to do is we tried to focus on picking each software that focused on a certain niche, and then making sure that we really evaluated, is this type of software that focuses on this specific target worth it for our council and needs as a whole? And that's why we tried to choose a wide variety of different softwares, because obviously we can't get to all of them, but we tried to get a good grouping under that umbrella of data storage softwares. So continuing on to the problems. With the problem plenty, there's a vast amount of the data storage softwares. So we were forced to choose based off the different niche topics as stated before. Coronavirus causing family issues, making sure that taking care of loved ones is a priority in the situation, lots of school conflicts as well. And then the final problem that we had was clicks versus specificity in terms of our data hierarchy, because a hard balance that I've experienced with my internships doing data science focused projects is a lot of engineers want to make everything as specific as possible, but then you have 20 plus folders, each with one document in it, and you're just clicking and clicking and clicking all the way down. And the search bar isn't very applicable to it, because the documents are named very specific item-oriented titles. So unless you know that direct title for the document, the search bar is not going to be too much help either. So really trying to find that good balance between being not too specific and being not too general as to not have thousands of documents in one folder was really a challenge for us. But I think we struck a perfect middle ground between it. Having focused on working documents versus finished documents, separating mentors and interns, and then keeping the teams all together, but then separating team folders into what they're currently working on versus what is finished. So for future projects for the database management team, I think a more robust hierarchy is required. I think we could lean a little bit more into specificity, but the problem with that is I think what we need to do is next year have individual meetings with each team and see what those teams require, because the storage formatting for, say, the EFS team is going to be drastically different from the database management team in terms of what files they're storing and what those deliverables are. So if we can find, if we look back through all the EFS teams' data storages, and then the ones that are, and talk to the current team, and we look at what they're storing each year and try to find some consistencies in the files, then possibly we can start making some folders that are recurring each year, and then also start specializing towards each team individually. Another thing that I think would be really good to focus on is working with each team and focusing on going into each meeting and asking them what they need in between each and every meeting, and seeing what they need for a file for storage in between all of the different meetings. And then also, I think it'd be a good idea to take the database management team and take one of the members and actually have them attend each individual team meeting so that they can keep consistently updating the database as needed. I think that would be a really beneficial thing, is to essentially lower the workload of one of the members and assign them purely to being the librarian essentially for the database, so that they could focus on managing the data for all the different teams as these different things come up. So effectively every Friday or any day of the week they pick, they just go through and clean up everything, and then see what the teams are inputting and where they can throw those files. So overall, how's ASME PDCC? The team agreed that we had great opportunities to network and great industry connections along the way. It was a great public speaking and leadership opportunity. It really helped us to build up networks and long-lasting businesses relationships. As oil and gas is a relatively close-knit industry, I'm sure that we're all going to see each other again at some point. So it's really good to build these networks early on so that we can leverage them in our careers going forward. So with that, do we have any questions?
Just a question, just kind of a broad question. I really like this presentation. And before I get to my question, I was just going to say, I think you all have hit on a key challenge that all engineers run into, all companies, is we have all this data. What do we do with it? How do we keep track of it? And how does it add value? And so I think that's a huge huge aspect. And I really like the fact that y'all have a manual that's been written. That's really helps with the continuity. Just a quick question. For the SharePoint, the one that you were looking at that was for SharePoint, did you all have access to the Petroleum Division SharePoint site, or what were you looking at it as like a standalone? Just curious about that.
We evaluated it based off previous experience with SharePoint, and then as well just looking into the different Microsoft resources that were available and just reading through what Microsoft had offered in the past. But we didn't look through the ASME one specifically.
Yeah, I'm not catching that. I think the mic might be off center.
You're a little quiet, Nathan.
Oh, is this better?
A little bit.
Okay, so we focused on just looking at the different Microsoft resources that were available online, and then also through personal experience, just going through that, but we didn't look through the ASME SharePoint specifically.
Okay. The reason why I was asking is I think the Petroleum Division Executive Committee has actually had some challenges over years with the very same issues that you guys were faced with in evaluating. So I really do appreciate the insights and ideas that you have on different options. So
I just want to add something to your comment, Brian. Something that I think industry folk definitely have a challenge with is when, let's say, you hire a data management team and they start moving data. Well, then you're going to have a lot of data directory issues in a lot of your engineering programs, and that's just going to cause more headaches and time consumption than if you didn't do anything at all. So there's definitely a balance to this.
Great work. If I can make a couple of comments, I just want to echo what Brian said, that this is a very, very important topic in the oil and gas industry right now. To put that in perspective, Petroleum Division has initiated an effort. Now it's a little bit bigger scope than this, but what they call big data and data management, digitalization in general. And we've got a task group of experts in the industry, Brian being one of them, where we're working actually to create some documents in ASME that capture some of these aspects. So very, very important topic. Another way to look at it, I can tell you that most of the operators in the oil and gas industry, they've got some programs working on this topic right now, and the challenges that they vary. Every company wants to do it differently, and that's why we at ASME Petroleum Division decided to see if we can find some common tools to get some of this work done. So well done, very important topic, plenty of opportunities in the future to expand on it and actually make an impact on the industry. So thank you.
I've got just a comment or so and then a question, but to add to that, we wanted a project here that wasn't so big that it would only get started in the school year we had. So that was part of the reason for keeping it within the Collegiate Council and not trying to incorporate it into other systems that would take a year before someone answered our email. And then the scale and scope of ours is small enough, it's probably not really needed. But so that was there was some conscious decision, not necessarily made to the group, but in how the mentors coached the challenge. My question, I think it was Nathan that was saying the idea of maybe having a librarian type role. Were you talking about just for 1 year to learn from it so that it can be set up better? Or were you talking that be a continuous type of position from year to year to year?
So, can everyone hear me all right? My speaker's a little messed up before.
Yeah.
But so I would recommend that it's a continuous role within the database management team. I know that we have teams that go in and out each year, but database management is one of those things, at least from my experience in internships, that it's a continuous process of upkeeping and formatting the data as your workflows change. So does the way that you're going to store data. So I really think it would be a really valuable thing to do is to just assign one of the team members to consistently keep everything clean, because I think a big problem that I've experienced, and this is anecdotal evidence, but my freshman year I was doing well view analysis with the different storage with the different data for drilling production, and just 1 year they didn't have someone upkeeping it, and that 1 year was a complete and utter mess. So it's really something that we need to focus on, continuously cleaning that data time in and time out, because all it takes is someone to take a week off and not keep cleaning it, and then you're going back through old well logs trying to figure out what someone was trying to say. So I really think it would be good to keep it a continuous cleanup. I'd say every week, just have someone go through and clean it up, teams.
Okay, thank you. Cool. Good work.
I just had a last comment, more of a question of curiosity for Jim or Brian or Don or who else wants to contribute. Does ASME has standards for material testing, calibrations and what have you, but do they have any standards for how to present data when it comes to like manufacturing specifications, like a pump? Do they have a way to express that data in a format that is so standardized that you can incorporate it right away in some of your programs?
Jim, I'll take first stab. There's a large number of organizations out there that for their specific type of equipment or their specific type of data that they might have they might have something out there. And so, for example, let's say a pump. If you have a pump, then there's things like API data sheets that would capture some of that data that you're interested in, like the key master data associated with a piece of equipment. But there's other data that's also captured. So does ASME have anything specific? Well, it depends. Like the performance test standards, you might have things out there, some of the boiler pressure vessel codes, but then there's other societies, entities that also play a key part in what we do. So it's a pretty complicated answer, but the answer is in general there are a lot of people that play in that space. Jim, you probably have a more intelligent answer than what I could provide there. So,
I think you covered pretty well, Brian. I don't have a lot to add, but I think it's fair. What you touched is that there's plenty of ways of doing that out there, but is there a consistent way captured in a standard that does that? Probably the answer is no to that. And really, our focus with that effort that I was talking a little bit earlier at now is to create a standard. And the intent there is not to create a standard to have a recipe for everything that goes on, because that's impossible to do. Is more of capturing a consistent process of how to manage data, process data, analyze data, and do some of those things. So I think that'll be very helpful. And one thing that we have focused on is keeping it practical, that people can actually use it, because there's a lot of standards and documents there, and some of them are meant for academia, some of them are not meant for industry, and so forth. So we're trying to get something simple that any user can follow it, a simple process that with practical application the user can use it.
And then I'll add, as I will on the simpler end of things, there's one thing about how organized the actual data is in the testing in this, but if you just look at the standards that ASME and API and these others write, the format of those standards will be reasonably consistent. You know, it'll have the definitions, it'll have the materials, it'll have process, and at the end it'll have testing and qualification, and in the middle you'll have descriptions of pumps, and here's what you need to gather and this and that, or here's how you test steel, or here's how the shapes of the members or beams or whatever it is. So there is some consistency, and some of the older standards will be a little different, but as they get updated, they tend to be updated to a format which goes a little bit back to the hierarchy. You want a basic level of it so you know where to go to. There's working documents and final documents, and that way you don't have to search through everything to find the last version that you guys came up with. But they're not so detailed that, like you said, you have a table of contents with 500 items and you only populated 13. So there is standardization there, if that was part of your question also.